Robotics and Automation. Robotics and automation have become integral components of modern industry and society, fundamentally transforming how tasks are performed in manufacturing, logistics, healthcare, agriculture, and even domestic settings. Over the past several decades, the evolution of robotics has seen the transition from rudimentary mechanical devices designed to perform repetitive tasks to sophisticated systems that can perceive their environment, make decisions based on complex inputs, and even collaborate safely with human colleagues. At the same time, automation technologies have evolved from simple mechanized processes into interconnected, intelligent networks that streamline operations, reduce human error, and enhance productivity across a diverse array of applications. The development of robotics began with early machines that were primarily used in industrial settings for tasks such as welding, painting, and assembly. These early robots were programmed to follow precise, repeatable motions on the factory floor, which provided immense improvements in speed and accuracy compared to manual labor. As computing power increased and sensors became more affordable and reliable, robots evolved to include feedback mechanisms that allowed them to adjust their actions based on changes in their environment. This early integration of sensor technology with mechanical systems marked the beginning of a more dynamic approach to automation, where machines could perform tasks with a level of flexibility that was previously unattainable. One of the most significant drivers of innovation in robotics has been the advent of digital control systems. Microprocessors and specialized controllers have allowed robots to operate with unprecedented precision. These control systems enable rapid adjustments during operation by processing input from cameras, proximity sensors, force sensors, and other devices. The fusion of real-time data processing with robotic motion control has resulted in robots that can adapt dynamically to changing conditions. For instance, in an automotive assembly line, robots equipped with vision systems can detect slight variations in component positions and adjust their actions accordingly, reducing errors and boosting efficiency. This combination of precise control and adaptive behavior has paved the way for new applications not only in heavy industry but also in fields such as medical surgery, where precision and reliability are paramount. Advancements in artificial intelligence have further broadened the horizons of robotics. Machine learning algorithms allow robots to learn from experience, optimizing their actions based on continuous feedback and large datasets. This capability means that modern robotic systems are not limited to pre-programmed responses. They can analyze patterns, predict outcomes, and even improve on their performance over time. For example, autonomous vehicles use a combination of deep learning and sensor fusion to interpret visual and environmental data, enabling them to navigate complex traffic environments safely. In warehouses, mobile robots utilize AI to plan efficient routes, manage inventory, and work collaboratively with human employees to fulfill orders. The integration of AI has transformed robots from rigid machines into dynamic systems capable of learning, adapting, and even innovating new methods for task execution. In addition to the technical improvements, robotics and automation have significantly impacted the economics of production. By automating repetitive and dangerous tasks, companies can reduce labor costs, improve safety, and increase output consistency. In manufacturing industries, robots can work around the clock with minimal downtime, producing components with high precision and reducing waste. This improvement in efficiency not only drives profitability but also helps industries remain competitive in a global market where speed and quality are vital. Moreover, automation has the potential to free human workers from monotonous tasks, enabling them to focus on areas that require creativity, problem-solving, and emotional intelligence, fields where human capabilities still hold the upper hand. The benefits of robotics extend far beyond the factory floor. In the field of medicine, surgical robots have revolutionized procedures by increasing precision and reducing the invasiveness of surgeries. These robots, guided by skilled surgeons, can perform complex maneuvers through tiny incisions, resulting in less trauma, faster recovery times, and improved patient outcomes. Beyond surgery, robotics is also making significant inroads into diagnostics, rehabilitation, and elder care. Assistive robots help individuals with physical disabilities perform daily tasks, and service robots are increasingly becoming a part of caregiving environments, providing companionship and monitoring vital signs. These applications highlight not only the utility of robotics in enhancing quality of life, but also the potential for automation to address the challenges of an aging population and a shortage of skilled caregivers. Agriculture, traditionally one of the most labor-intensive industries, is also being transformed by robotic automation. Autonomous systems are now used for planting, monitoring, and harvesting crops. Drones equipped with multispectral cameras collect data that inform precision farming practices, enabling farmers to optimize irrigation, fertilization, and pest control. Automated harvesters can operate for extended periods, reducing the reliance on seasonal labor and significantly increasing crop yields. This integration of robotics in agriculture is not only improving efficiency but also contributing to sustainability by minimizing resource wastage and enabling more targeted application of agrochemicals. In the logistics and supply chain sector, robotics has ushered in a new era of efficiency and responsiveness. Automated guided vehicles, AGVs, and autonomous mobile robots, AMRs, navigate vast warehouse spaces, transporting goods swiftly from one location to another. These systems are integrated with sophisticated inventory management software that tracks items in real time and optimizes storage and retrieval processes. The result is a smoother, faster supply chain that can adapt to fluctuations in demand and mitigate the risks of human error. With rapid e-commerce growth, such automation is essential for maintaining competitive delivery times and enhancing customer satisfaction. Another critical arena where robotics is making a profound impact is in construction and infrastructure. Robotic systems are being developed to undertake tasks ranging from bricklaying and concrete pouring to complex demolition and site surveying. The application of robotics in construction not only improves precision and speeds up project timelines, but also enhances safety by minimizing human exposure to hazardous conditions. Although these technologies are still maturing, early demonstrations have shown promising results in terms of scalability, reliability, and cost-effectiveness. As these systems become more advanced, they are expected to revolutionize the construction industry, contributing to smarter, more sustainable building practices. The integration of robotics with automation is also transforming the energy sector, particularly in renewable energy plants. In wind farms and solar power installations, automated robots perform maintenance tasks, inspect equipment, and even manage the operation of entire facilities with minimal human intervention. These technologies increase operational efficiency while reducing downtime and maintenance costs. As the world pivots towards sustainable energy sources, robotic systems will play a key role in ensuring that renewable energy infrastructures are both efficient and resilient. Despite the remarkable progress, the deployment of robotics and automation is not without its challenges. Technical hurdles such as sensor reliability, system integration, and the complexity of real-time decision-making remain significant obstacles. Moreover, there are socio-economic concerns, including job displacement and the need for workforce retraining as automation technologies become more pervasive. Policymakers, industry leaders, and educational institutions are increasingly focused on addressing these challenges by developing frameworks for the ethical deployment of robotics, investing in res-killing programs, and fostering collaboration between humans and machines. The goal is to ensure that the advancements in robotics not only drive productivity but also contribute positively to society by augmenting human capabilities rather than replacing them entirely. As robotics and automation continue to advance, future developments are likely to see even deeper integration between these systems and artificial intelligence. Robots that can reason, infer, and interact more naturally with humans will appear in sectors ranging from customer service to creative industries. The concept of collaborative robotics, where humans and robots work side by side in shared environments, is already being realized in several industries and is expected to become increasingly common. This collaboration will lead to enhanced productivity, greater innovation, and improved working conditions, as the strengths of both humans and machines are combined effectively. Furthermore, the convergence of robotics with other emerging technologies, such as the Internet of Things, IoT, and edge computing, will facilitate the creation of highly connected, intelligent ecosystems. In such environments, robotic systems will not operate in isolation but will be part of a larger network that shares data in real time, resources are dynamically allocated, and decisions are made collaboratively across platforms. This integrated approach will lead to more robust, adaptable systems capable of managing complex tasks in unpredictable environments. Such innovations have the potential to revolutionize disaster response, environmental monitoring, and even space exploration, where autonomous systems can perform tasks in challenging and remote locations. In conclusion, robotics and automation are driving transformative changes in industries around the world, ushering in an era marked by enhanced efficiency, safety, and innovation. The journey from basic mechanized tools to advanced intelligent systems reflects decades of research, development, and continuous improvement. As these technologies continue to evolve, they promise to redefine how we live and work by automating tedious tasks, augmenting human capabilities, and opening up new avenues for creative problem-solving. With applications spanning healthcare, agriculture, logistics, construction, renewable energy, and beyond, the integration of robotics and automation is set to play a pivotal role in shaping the future. The challenges that arise with these advancements bring about the need for balanced strategies that address technical, economic, and ethical considerations, ensuring that the benefits of these technologies are realized across society. This expansive evolution in robotics and automation not only accelerates the pace of innovation, but also reimagines the relationship between humans and machines, forging a path toward a more efficient, intelligent, and harmonious future.